and is x to the 4th power less than 9 x to the 2nd power. Remember, guys, this is extremely important. Okay, you move everything to the left because right hand side must be 0. This is important, extremely important. Now the expression that you have on the left hand side, you factorization, no? The greatest common factor is x squared. We have x squared minus 9. Okay, of course, factor completed. There's x squared here, and this is different of a square. Okay, it's x33 plus or minus. Okay, and this is our inequality. Okay, I enclose in the box because the new one is easier or relatively easy to analyze. The original is, of course, impossible. Okay, now, entonces in this case, I can see new situation que is not new, pero you know, when you have exponent, you have factors que contain exponent even like this. So you need to make decision, see we can delete or totally delete or partial delete. What do you think? Partial delete or totally delete? Totally or partially? You remember that or no?
To clarify, when it's without the equal sign in the sign, is it partial? I don't remember, but it depends on the sign.
No, when you have equal sign, here, you can totally delete. When you have no equal, it's partial. Okay? It's the only thing that you have to remember, right?
Okay, thank you.
Therefore, you take, so my inequality, I modify, simplify something like that, like x. So this statement is equivalent to 100% to say x plus 3, x minus 3, less than 0, and no 0. Because 0 is the fact, is the 0, ¿no? que incluye the factor x squared. So basically, this inequality, you consider only the factor x plus 3, x minus 3, with the same sign, less than 0, but the only detail is that you consider in 0 we have a whole, and the reason is clear, because suppose 0, so you plug in 0 here, 0 squared, 0 plus 3, 0 minus 3, less than 0. Es obvio que this statement is completely false because this is 3 and this is minus 3, no? But this is 0, and multiplication by 0 is always 0, and 0 is no less than 0. Okay, entonces tú consider que true statement, you exclude 0 in the game, so no 0. And you know in 0 we have a whole, and that's it. Okay, so now you focus in this inequality. Solving this under the only consideration that in 0 we have a whole. Clear? Entonces the critical value, remember, is the 0 of the polynomial x plus 3 equals 0. Es obvio que es negative 3. And x minus 3 equals 0 es obvio que es positive 3. And this is the critical value. The critical value, as always happens, help me to make a partition of the all real number line. This is all real number line. Mm-hmm. 0 degree, horizontal line. This line represents all real number from infinity positive, infinity negative, Actually, we investigate different interval, and the critical is -3 and +3. If we have two partitions, we have 3 different intervals, and you select totally arbitrary testing point inside to verify that this interval satisfies the inequality or not. Suppose I select in my paper -4. I select in my paper -1. No 0, because 0, you know, we have a hole, no? To make sure I am confused a little bit, maybe you select +1, but I suppose that not necessary, because the nature of -1 and +1 is the same. But okay, suppose that I am not sure, no problem, you can do that. And 4, this is my testing point. So you create immediately the table. The table is useful to testing the point. It's the one, you know, shortcut, easy way. You can evaluate the original, that's it. But no. In -4, -1, suppose I select +1 to make sure, because I am not 100% sure that I can separate or no, and +4. And the factor involved in my problem is x + 3, it doesn't matter the order, and x - 3. As always, the extra column to summarize the signs. Remember, the information inside this table is only signs, positive or negative. And you evaluate one by one into the, in this case, each factor. This is negative. I suppose you understand very well this, no? -4 + 3, plugging in this value here. Is -1. I know the -1, but I put only negative. It's the only information, okay? It's obvious we need. This is negative also. This is positive. In the total column, I put in the circle because this is the information I need. Well, let's fill out the table quickly. Plus, minus, plus, minus. You see, get the same -1. That's the same behavior. It's, you know, at the beginning, no total expecting, but I realize now. And 4 is plus. And plus is plus. We come back again to the original inequality. And remember, our original inequality has less than 0. Look, I copied that part. And less than 0 means that the true statement in the table is the negative guy, and this and this. And this. Okay, actually, it's only one interval, no? So you highlight this. This is the solution of the inequality. However, don't forget that in 0 we have a hole. Because in 0 we have a hole, that means we have here a hole. This is 0. But actually, my interval is from -3 to 0. In 0 we have a hole, 0 to +3. Okay? And so what is the answer? The final answer is then -3, 0. In this case, any endpoint is considered like a parenthesis, because this is an inequality, it's a strict inequality, no have no equal sign, because it have no sense to think that we take inside the solution the endpoint. No. Entonces es -3,0 union, because it's two intervals and you collecting by union 0, +3. This is the answer. Okay, in this case, corresponding with the option, let me see, -3, 0. I suppose que es B, no? Yeah, I suppose que es B. This one. You let me know if I make a mistake to select. Everyone follow me? Everyone understand very well this first example? 15. It's clear, confusing? Question, guys? No?
It's clear.
Okay. Remember, this is a review. So I need to make sure that you understand very well, no? Because this is the last opportunity you have before the test to summarize and go over again to the same thing, right? So don't hesitate any question, any minimum question that you have. Professor, could you repeat again? This is a moment, no another moment. Okay, let's move on 16 now. 16 is different. It's another inequality, of course, but it's a polynomial degree 4, 21x squared minus 100 greater than 0. Okay. 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 Bueno, I appreciate so much that the right hand side is 0. I don't need to create that, no? Now I focus in the factorization this polynomial, ¿no? Que es de degree 4. Ok, no problema. Pero es trinomial. Es trinomial, entonces the factorization is square root this guy is x squared, and the combination in 10 and 21 is 25 and 4, because 25 times 4 is 100, and somehow 25 minus 4 is 21. And the sign is negative 25 and positive 4. Now remember, I need to factor complete it. Therefore, I can see here a difference of a square, and the factorization is x 5 plus or minus. However, unfortunately, we have a sum of the square que I know que es the classical irreducible quadratic, because the factorization, this is in the imaginary complex field. Do you understand very well this?
Yes.
You have? Sure? Okay. Now, this is a crucial moment. I enclose in the box this in the box. Oh, no, not yet.
Wait, I have a question.
Go ahead.
Why don't you separate the x squared minus 4 into x plus 2x minus 2?
Good question. Because see, you have this, it's a difference of square. I agree 100% with you. It's xx 22 plus or minus. This is the classical differences of a square. But this is sum of a square. Entonces, I know que sum of a square is prime expression. Is considered like a prime expression. Prime expression means in the real field. However, in the complex field, you can factorization, but different. Let me show you how. You can factorization like two parentheses saying xx plus 2i and 2i, positive and negative. Let me try to verify that this is correct. You FOIL now, FOIL here, FOIL. Multiplication, x squared. Multiplication is minus 2ix. Multiplication, this is plus 2i x. And multiplication, this and this is negative 4i squared. No? This is cancelled, disappear the imaginary part. I squared, I know, get negative 1. And negative 1 and negative 1 together become positive 4. Do you understand now?
Yes, I understand.
You need to be aware. When you have difference of a square, is possible factorization. Nice formula, everyone know. Sum of the square in the real field, no. It's prime expression, and leave it like that. And this is called irreducible quadratic expression. This is called, there are different names, no? Irreducible quadratic expression. Good. Good or not good? Let's continue. This is an important moment now. We can delete or no something in order to analyze our inequality. We can delete x squared plus 4 and totally delete or partial delete. Opinion. Delete. Do you understand the idea for the delete? So the idea for the delete.
Partially.
Partially, you say?
Yes.
No, totally. Let me explain why. Okay, do you understand in the previous example, this factor I partial delete? Do you remember, right? The reason is because this is a parabola. And the parabola touch the x-axis in 0. That is the reason that you consider it partial, because you enforce the restriction no 0. However, what happened with this guy? Factor. Now, this factor is also parabola, but we have 4. And 4 represents vertical shift, 4 units up. So 1, 2, 3, 4. You see that this expression is always positive, never 0. Therefore, in this case, you can totally delete. Do you understand this or no? Remember, the challenge is, be careful when you have factor like that. Suppose x minus 2 squared. Well, this is a parabola also, but this parabola passing through 2, but touch here the axis. So in this case, depending, no, si we have equal sign or no equal sign in our inequality or reaching inequality, suppose that you have, no, so you partial delete, pero the restriction is x no 2, because I know that in 2, this parabola is 0, and 0 is no greater than 0. This is the idea, but in this parabola never is 0. Do you understand very well or no? Yes or no? Let me know. Guys, come on, communication. Yes, good. Okay, entonces you need to be aware, partial delete, totally delete. When the factor normally happens, when the exponent is 2, 4 even, you delete. But see, the format of the factor is like that, x squared plus 4, entonces obviously que you totally delete. Si es totally delete, entonces my new inequality is easier is this. Sorry. We focus now in this inequality. Okay? The critical value are 5. Okay, negative 5. Another critical value is positive 5. We using as always this critical value to make it partitions of the all real number line. Okay, 5 positive and 5 negative. And you say totally arbitrary testing point inside each interval, negative 6 or negative 7 or negative whatever. 0 is good. In this case, no hole in 0. So 0 is considered a nice guy. And maybe another student say, no, I don't like 0, I like 1. Okay, no problem. So any testing point is representative the behavior of the inequality inside this interval que is from negative 5 to positive 5 and 6. Okay, ready to make a table The table is, you know, we have one first column listing, sorry, the testing point, and the rest is the factors. Okay, need to evaluate, que es x plus 5, x minus 5, and you include one extra final column with the total information. Okay. Okay, this is negative, it's obvious, no? Negative 6 plus 5. This is negative 11, negative 6, and then this is plus. Remember, two negative multiplication is positive. 0 is positive. Here is negative, negative. 6 is positive. And positive is a positive. Therefore, the testing point que passed the test was negative 6 and positive 6. Now I discovered that this is negative 6, not stop in negative 6, because negative 6 is one, you know, hypothetical number que I select, another student select another negative 7. So no. Our interval extending from extending from negative infinity to negative 5, including negative 5? No. Why no? Because our inequality no include equal sign. Entonces, the symbolic way to indicate this idea is using parentheses here. Therefore, our final answer is from negative infinity, comma negative 5, union, positive 5, comma infinity. ¿Qué corresponde with the option D? I guess so. Now let me see. Oh yes, this option. Any question? Any question? No? Clear, super clear. Do you understand 100% everything?
Yeah.
Okay, this is my way, okay? My habit to solve this. Some people solving a little bit different. Don't like the table, and you can, for example, evaluate directly. For example, in this case, it's easy because you evaluate, not necessarily evaluate factor by factor. No. You evaluate, for example, negative 6. You evaluate here. You copy. Negative 6 plus 5. Negative 6 minus 5. I need to test it, see it's greater than or no equal to 0. This is negative 1. This is negative 11. And negative times negative positive 11 greater than. This statement is true. And you put true here. I don't necessarily do the table. I prefer the table. The table is useful in the complicated example that have several factors. And it's a fantastic way, in my opinion, to organize the work. Clear? Erase the board or not yet?
You can erase.
Excellent. Let's move on to the question 17, 18, and 19, que is basically the factor theorem. So it's easy. You are doing synthetic division, and in the remainder we have 0. So you want to investigate if this polynomial or this factor belong to this polynomial. You are doing synthetic division, no? When you get 0 remainder, it's because belong, no? So you get another remainder, no 0, entonces no factor. The polynomial is given is x cubed plus 2x squared minus 6x plus 8. Yeah, I need to investigate if the factor x plus 4 belong or not to this polynomial. Sometimes it's impossible or super complicated doing by the regular classical factorization. No, more powerful is scientific division. Or more powerful is a combination of both. The regular factorization that you know in intermediate algebra plus the new idea for the scientific division. The organization on the format for the scientific division is you copy the coefficients 1, 2, negative 6, and 8. And you divide by x plus 4, but the only detail you have to remember is you copy this guy 4, but opposite sign, negative 4. Okay, this is the format, guys. Don't forget. The rest is super easy. You bring down 1 multiplication is negative 4. You combine here is negative 2. Multiplication this and this is 8 positive. Combine here is 2. Multiplication 2 times negative 4 is negative 8. And remain the 0. Therefore, yes, this factor x plus 4 belongs to this polynomial. Okay? Another way to understand this. Another way, but no, this is enough. You are doing this here, 100 points for you. But I need to explain another way, no? Suppose que, pero es more, no complicated, but long. You evaluate the function in negative 4. You plug in negative 4, and the original polynomial you have negative 4 cubic plus 2 times negative 4 squared minus 6 times negative 4 plus 8. Entonces negative 4 cubic es en negative 64. Because 4 times 4 times 4, 3 times, but when exponent is odd number, stay negative, no? In this case, no. In this case is 16 positive times 2 is 32 positive. We have 24 positive and 8. Entonces 32, 24, and 8. I adding the positive guy is, you know, is 14, carry down 1, is 64, pero positive. Actually, it's negative 64 plus 64 is 0. We prove in the same idea. You know, it's more complicated when you have 5th power, 6th power, crazy. I don't know, using calculator, of course. But actually, the thing I want to illustrate is the scientific division, the only thing you are doing is in the shortcut, in one easy way, plugging in this 0, so this factor, this is a factor, however, this factor is associated with the 1, 0, okay, this 0 is x equal negative 4. The thing I'm doing in the scientific division is plugging in negative 4 into the polynomial, and they see the answer is 0, que represent the remainder of the scientific division, and because the factor belongs to the polynomial. Got it?
Can you also do it through long polynomial division?
Say again?
Can you also do it through long division? Like solving?
Yeah. Good question. Excellent question. I like to hear that question. So, long division means it's more general. Okay, you can divide any polynomial divided by another polynomial. But frequently, we use a long division when, for example, you have degree 3, in this case, degree 3, divided by degree 2. But in this case, it's special, because you are doing degree 3 divided by degree 1. Because you know, okay, the degree of this factor is 1, no? It's a linear factor. When this situation happens, when the degree of the divisor is 1, entonces es much better, o sea, it's a shortcut doing synthetic division. Synthetic division. Entonces, long division you can do in general for any situation. In general, for any situation. Long division is specifically when the degree of the divisor is 1. Clear?
Yes, thank you.
However, either way, so you, for example, in your test, and the solution of the test you are doing by long division, it doesn't matter if the degree is 1, I agree, right? It's correct. Okay? It's correct. So now the answer for the question say yes, no? Yes. Any other question? Smart question. Like this. Que help me to explain one thing que I suppose que you know, but actually it's important, reinforce the idea. Okay, let's do number 18 now. 18 is a polynomial 4 degree. It's x to the 4 power plus 12 x to the given power plus 4 x to the second power plus 40 x minus 96. I need to investigate if the factor x minus 12 belong or not to this polynomial. Okay, so I make a decision to do using synthetic division. Okay, so I copy the factor, okay, 1, 12, 4, 40, and negative 96. Yeah, and don't forget that this number is the opposite sign of this. See, the factor is x minus 12, the number is positive 12. Bring down 1 without do any operation. No, don't do anything, just bring down. And multiplication, 1 times 12 is 12. And 12 plus 12 together is 24. 24 times 12, you put in the calculator, of course, I did that, is 288. Now combine, this is 292. Wow. And you see that the number increasing, blow up, increasing too much. Entonces, I suppose que, well, I don't know. It continues. You multiply 292 times 12, and the answer is 3,504. Together is 3,544. A multiplication by 12 is big number, 42,528. And when you combine this and this together is 42,432. And the answer is no. And no, why no? Because the remainder is not 0, it's 40,432. If you evaluate the polynomial n12, I guarantee you 100% that you get this answer. Okay? This is you can do using the calculator, no? Then the answer is no. Everyone follow me? And number
Yes,
18,
yes.
yeah, number 18, no. This factor that they propose us, no, doesn't work. Okay, now let's move on to the 19 problem. 19 is more interesting. Okay. 19 is a polynomial degree 6. Wow. F of x is equal x to the 6th power minus 13, x to the 4th power minus 52, x to the second power plus 64. I need to verify if this polynomial is divisible or contain, gets the same, is synonymous, the factor x minus 4. Now let's organize synthetic division. Degree 6. Be careful, because in this moment, the factor gets missing. For example, the factor, the exponent 5 is missing, the exponent 3 is missing, the exponent 1 is missing. But to organize this in an elegant way, in my opinion, you copy x to the 6, x to the 5, x to the 4, x to the third, x to the second, x to the 1, and x to the 0. It's the different degree. And you copy the coefficients. 1, this is 0 is missing, to the 5th is missing, negative 13. And QB is missing also. Okay, x squared is negative 52. This is missing, and this is 64. And you divide by 4, remember, no? Okay, it's the opposite side of this. Everyone follow me in the organization of this? That part is not strictly necessary. You lie, it's okay. Do you lie or no? No?
Yes.
No.
Erase?
Yes.
No.
Actually lie. Opinion, yes, no. Okay. Now let's do it. Bring down 1. Bring down 1. Multiplication 1 times 4 is 4. 4 plus 0 is 4. 4 times 4 is 16. Now we combine here at 3, positive 3. 3 times 4 is 12. 12 plus 0 is 12. 12 times 4 is 48. Entonces negative 4, no? Negative 4. And negative 4 times positive 4 is negative 16. 0 and 16 is negative 16. And negative 16 times 4 is negative 64. Nice. 0 remainder. Now, yes, the factor x minus 4 belongs to that polynomial. So when you are doing the factorization, you can include x minus 4, and the rest, well, I investigate it. But I don't care. The answer is yes, this factor belongs to the polynomial. Any question, guys? Do you understand very well or not? It's super easy, but super powerful. The zero factor theorem. Good or not good?
Good. Good.
Yeah. We continue. We practice a little bit now. Descartes rule. Descartes rule is super easy also, but you need to analyze using Descartes rule. You need to analyze the number, how many change of sign we have in our polynomial. No? Suppose in the question 20, the polynomial gets given is minus 6x to the 9th power plus x to the 5th power minus x squared plus 7. Not necessarily complete. In this case, the Descartes rule not necessarily complete. See, one term is missing, I don't care. The problem is you analyze how many change of sign. For example, let's use a different color. For example, red color for the positive and blue color for the negative. So red color for the positive and blue color for the negative. So in this case, the original is given is the positive. So you see, negative 6 is negative. Positive 1 is positive. So we have one change of sign. Do you see that? Negative to positive. Doesn't matter if it's negative from negative to positive or from positive to negative. In this case, from positive to negative, another change of sign. And now negative to positive, another change of sign. What is the fantastic conclusion? PS 3. Actually, the number of the positive 0 is 3 or 1. Because Descartes discovered or state the rule que say que the number of chain of sign is P, you subtracting 2, subtracting 4, subtracting even number, and decreasing the number, no? You know, 3 minus 2 is 1. 1 minus 2 again is negative something, negative 1. No, negatives have no sense. Entonces, Descartes say, well, okay, you have two possibilities. 3 positive, 0, or 1. I don't know exactly what that, but this is the idea. Now I make a reflection. When you make the reflection for a polynomial to investigate the negative part, Bueno, remember, the factor que contain exponent odd change, but the factor que contain exponent even stay the same. Makes sense, right? Do you understand this idea? Yes. Then I analyze the sign one more time. Positive to negative. Negative to negative, stay. Negative to positive. Okay. Now M is 2. Therefore, the number of negative is 2 or 0. This is the only possibility we have. Do you follow me? Entonces I need to select something, what option matching with that condition. We have degree 9 in this polynomial, degree 9. Degree of our original polynomial is 9, degree 9. Degree is 9. The number of positive is 3 or 1 positive, and the number of negative is 2 or 0. Okay, entonces 3 or 1 positive, 3 or 1 positive, and 3 or 1 0 negative. It's supposed to be the last option, no? It's the last option, option D. Yes or no? Option D.
Yes.
Yes.
Yeah. Do you understand the idea behind the Carter rule? It's super easy. Super easy. Only organize. My recommendation is organize in this way. No sé, I don't know. I like this way. So when I studied, when I was a student, and the teacher explained me, I create my own way, and this is the way that I present to you, no? So you like, you take it, you create another, because this is the cosmetic part, no? How you interpretation this? You count how many chain sign we have in the original polynomial, no? Okay, and you decreasing by even number 2, 4, 6. And likewise, you obtain the reflection, and the reflection give me the information for the negative 0 of the polynomial. Any question? No? Good. Let's do another example. We have several. We have 21, 22, 21, 22. Let's discard the rule. 21 say the function is 8 x to the a power, degree 8 minus 4 x to the 7 plus x to the 6 minus 4x plus 8. Okay, it's doing. So now the positive guy is one chain of sign here, another chain of sign, another chain of sign, another chain of sign. PF4. 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 And P give me the information about the 0, so positive, that is the idea, is positive real zeros. In other words, is the excellent set and the positive part, so greater than 0. And you're subtracting to say you 4 minus 2 is 2, so F4 is 2 and yes 0. You have 3 possibilities. Now reflection, make a reflection. Remember the reflection. The even is stay the same. This no change. This stay the same. This no change. And this of course stays the same. It's obvious that we have no change sign. Everything is positive. N is 0. That means that the negative real zeros in this polynomial is 0. Oh, in other words, do not exist. Oh, in other words, no. What? No negative, real 0. Entonces es the option, let me see. I suppose degree 8, 420. I suppose que es de 8. Yes or no? Yes or no?
Yes. Yes.
Yes. Good. Let me erase. See, you let me know. So you let me. I can erase the board. I down low on the next page. Yes or no? Erase, right?
Yes. Yes.
Okay. Next. Let me try. Let the review. 2. Okay, what page? Remember, my intention is doing this review today and this Thursday. And in the next lecture, I will send the written test by email. And remember, the due date for submit the test number 2 online in Alex is March 1st. In other words, next Tuesday. Next Tuesday is over. I will start a new chapter. Are you clear? Are you clear?
Clear. Clear.
Okay. X to the 6th power plus 4 x to the 5th power plus 4 again x to the 4th power plus 3 x to the 3rd power minus x squared. Wow, too long. Minus 5x plus 4. Okay. Now let's analyze the chain sign to find the p value. P, capital P, represent the number of chain sign. Well, this is positive. Positive, 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 positive. Oh, I discovered one here. This is stay the same. And finally here, another. So P is 2. Therefore, the positive is 2 or 0. Now reflection. This is the same. This is the change. This is change. This is stay the same. This is change, and this is stay the same. And now, when you analyze the negative, one chain of sign, another chain of sign, another chain of sign. No here. One chain of sign, no here. Actually, 1, 2, 3, and 4. N is 4. Now the number of negative is 4, 2, or 0. Is the option D, I guess so. Yes. And I am right or I am wrong? I am right.
Yes. Yes. It's correct.
Entonces, descarte rule is easy. I suppose in the question, in the test, we have one question of descarte rule. You have no problem to do that. Okay, let's move on to another case, listing the potential rational zero of the polynomial. Remember the formula que is P over Q, plus or minus. Es the you guessing, no? The potential rational zero of the polynomial, no? The formula, well, the formula is the famous formula that we discussed, is plus or minus P over Q, no? P is the first number, the last number, so when the degree is 0. and Q is when the degree is maximum, so M. Okay, let's do it. We have this. F of x is equal 6x to the 4th power plus 3 x to the power minus 4 x to the 2nd power plus 2. Who is P? No, P is 2. This is P. And who is Q? Q is 6. And my formula is plus or minus P divided by Q. Okay, our specific example is plus or minus 2 over 6. And no reduce, no reduce and lower term, no. This is how you reduce it 1/3. No, don't do that. Because I need to discover all combinations. And combination is, and the 2 is plus or minus 1 and plus or minus 2. And the 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. What mnemonic divide to verify that we're doing well is you multiply this guy. 1 times 2 is 2. Nice. And you multiply it like that and like that. It's 1 times 6 is 6 and 2 times 3 is 6. So this is the all possible factors of 6. Okay, there are many ways to do that, but in my mind is now you list the potential is the any combination. You select one guy in the top and every guy in the bottom, another guy in the top, everyone in the bottom. Entonces, suppose que I select here. There's 1, so plus or minus 1. I select 1, so I fix it 1, and with the 1 and the 2. After we fix it 2, this is one possibility, no? Actually, in total, we have 1, 2, 3, 4, 5, 6, 6 or 8 combination because it's 4 times 2. But some combination is repeated and you consider it only one time. Entonces, plus or minus 1, plus or minus 2, where come from this? Well, this is the combination, this and this, and this and that, right? Another possibility is 1/2 is 1 and 2. Another possibility is 2 and 2, but 2 and 2 is 1. So I have that. No necessarily repeat again. No. So you repeat it's okay, but not necessary. And plus or minus 1/3 is 3 and 1. And plus or minus 1/3, 2/3, no? 2/3. And finally, plus or minus 1 over 6, no? And 2 over 6 is 1/3. I have that. This is the combination. Get the option B. Any question? Do you understand very well this idea?
Can we also over 6, even though we could reduce it to 1/3 on the written test?
I don't understand me. Speak slowly and loudly.
Like if we add 6 and 1/3, is that fine on the written test?
Yeah, of course. I understand you asked me about the order, no? Okay, it doesn't matter. Yeah, it's a, look, this is a set. And the important property when you listing a set is that no repetition is necessary. And the order, it doesn't matter. For example, the set Maria, Jose is exactly the same set Jose, Maria. The thing I try to explain is that it doesn't matter the order when you're talking about set. It's the same. It's like a thing. It's the same thing. And it's the same Jose, Maria, So no necessarily repeat Maria, because it's the same person. So si es Maria 1 and Maria 2 is a different person. Okay, entonces, conclusion. When you're talking about set, no repetition is necessary. Si you are doing repetition, no big deal. Okay, but no repetition is necessary, and the order is not important. Okay. Another collection of the set in mathematics and set knowing arrangement. The order is important, but in this case, no. Got it, got it, got it? Sure?
Yes.
Okay. Let's move to 24. 24 and 25 is the same. (24 and 25). 24 is f of x is equal minus 4x to the 4th power plus 3x to the 2nd power minus 4x plus 6. And it's a p in our example, and it's a q in our example. But you don't care because the formula says plus or minus p divided by q. Entonces now, si you consider both possibilities, plus and minus, entonces I don't care this sign. This sign is not important. Actually, it's plus and minus 6 over 4. Okay? You consider positive because the consideration for the sign is here and that part. No simplification because I need to consider every possibility. And you have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And the bottom is plus or minus 1 again, and plus or minus 2, and plus or minus 4. Because 4, you know, you obtain for the multiplication 1 times 4 and 2 times 2. And 2 is repeated. Now the list of the potential zero. Of course, guys, this theorem give me some idea. But you need to prove that this zero work or doesn't work doing the scientific division, ¿no? One by one, but this is too long process. Okay, entonces plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. I obtain this combination using this divided by each in the top. Now 2 is 1/2. 2 over 2 is 1, I have 3/2. 3 divided by 2, and 6 divided by 2 is 3/2. Not necessary. Now 4, 1 over 4, 1/4, and 3/4. 2/4 is 1/2, k/2. Not necessary repeat, and 3/4. And 6 divided by 4 is 3/2. I have that. This is the combination, que is the option B. Let me see. Yes. The option B. I don't know. Say, I suppose. In different order, no? But it's the option B. Yeah. Can do it well or no? You let me know if I make a mistake. Because I am bad in the selection. Okay? Everyone follow me? Everyone understand very well? This is easy. It's no big deal. This is called, the name of this is rational zero theorem. Rational. And the theorem, rational zeros theorem. Unfortunately, the theorem don't guarantee that this is true. There are a counterexample in which we have no. So you apply the theorem, you get the list, and when you work in one by one, doesn't work. This is the, it's the most typical. The most typical is you find something inside the list. But this is unfortunately, this is the idea. 25 is f of x is equal 5x to the 5th power minus 6x to the second power plus 6x minus 1. Again, this is p. I don't care the sign, and it's a q. And the formula is plus or minus p divided by q. And our specific is plus or minus 1 divided by 5. Wow. So in the top we have only one possibility, get 1. In the bottom, well, in the bottom we have 1. Well, 5 actually. But 5 is 5 and 1 and 5, no? Because 1 times 5 is 5. The combination is obvious, is plus or minus 1 and plus or minus 1/5. Que in my opinion is the combination de option A. Everything is okay or no?
Yes. Yes.
Okay. Any questions so far about rational zero theorem? How you apply that? No? Okay, let's move on to the 26, 27, 28, 29. Let me see, 29, 30. Okay, basically is factorization. Using rational zero theorem to find all the real zero of the polynomial function. Using the zero to factor f over the real number. O sea, no imaginary, only the real, and some expression que es irreducible quadratic. Stay the same. Let's move on to the 26. 26 is f of x equal x to the fourth power plus 24 x to the second power minus 25. So in this example, in my opinion, this most important example, 26, 27, 28, 30, 29, we're using the combination of the regular factorization that you know in intermediate algebra, and synthetic division if necessary, right? And using zero factor theorem, much better using Desmos. So in Desmos, you do the graph of this, and you visualize what is the real zero, positive or negative, and you using this in the synthetic division, because another way is very, very long and stupid, no? See, we have the tool of Desmos to do the graph. Of course, we are doing step by step, and we share the Desmos to you see clear the idea. So in 26, in my opinion, it's easy because it's a trinomial, no? And this trinomial, the factorization is 2 parentheses, x to the second power, and the combination is 25 and 1, because 25 times 1 is 25, and 25 minus 1 is 24, of course, positive 25 and negative 1. Entonces, one more time happen. We have this expression that is irreducible quadratic. It's impossible factorization in the real field. And the complex, yes, but no. The equations say real. So leave it like that. Don't touch this. Now, this, we need to continue factorization. And this is xx 1 plus or minus. Entonces, this is the factorization. There are no more possibility. Complementary to this idea, we need to listing the zeros. This is the factors. So my polynomial, you can write like that original. However, no. I did the factorization like that. Beautiful. In this factorization, we have 2 real factors, que es this and this. And we have another factor que, unfortunately, is irreducible quadratic. It's imaginary. Pero no. Now, I am listing now the zeros, real zeros. real zeros. Well, what is the real zero? Well, the real zero are obviously -1 and +1. Okay, the zero, this and this. Entonces, in this case, the option D is the correct, I suppose. Everyone following? Just in case, to make sure everything is okay, I want to open decimals. I create one decimals for this moment. We are talking about question 26. Do you see decimals or no? Yes, no? Yes?
Yes.
Okay. Look at that. This is the, well, at least you see one piece of the polynomial, but the important piece, you make a zoom, no? You want to make a zoom. Zoom in, zoom out. It's okay. It's look, look like a behavior is right up, left up. And makes sense because the dominant is to the 4th power, no? But the real zero is in +1 and -1. Do you see now? This is the verification that we are doing well. Doesn't matter that you are doing by regular factorization or by synthetic division. Let's come back again to the whiteboard. Please, any question that you have, let me know. Super clear? Everyone follow me?
Super clear.
Super clear. Super clear. That is the reason, Miss, that we are the best in Miami-Dade College. So this class is the best. I am not super good, but I am dedicated teacher, no? You are pay attention. Don't hesitate to ask me any question. And little by little, you improve your skill. Okay, 27, I have no idea. 27 is f of x is equal x to the cube power plus 2x squared minus 5x minus 6. In this example, it is impossible, at least for me, doing the by regular factorization. You take, for example, in the zero factor theorem, you take this is P is 6, Q is 1. Entonces plus or minus P divided by Q, in our specific example is plus or minus 6/1. So the possibility are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and plus or minus 1. I suppose the theorem do not guarantee this. But okay, to make sure, of course, I want to go to decimals. I put a polynomial. I try to see what is the real zero, positive or negative, in the question 27. Okay, and try to find my laptop. Okay, there you go. I find my laptop. Keep in mind this idea. Okay, okay. I go now to decimals. Okay, decimals. Okay, I have that. I suppose you see decimal now. Yes or no? We are talking about question 27. Look at the question 27. Do you see that or no?
Yes.
Entonces I discovered, wow, the real zero is located at +2, at -1, and -3. Entonces I use either and verify this using synthetic division and my original polynomial. Got it? It's doing. Okay, remember, +2, -1, and -3 is my is my 0. Is my 0. Okay. I come back again to the whiteboard. Boom. Do you see that? Okay, I copy now my synthetic division. My synthetic division is 1, 2, -5, -6. I try, for example, it doesn't matter, the order is not important. I try to, I don't know why I like to, positive 2. Okay, positive 2 guy is this guy, positive 2 and positive 1. Okay, I try. Bring down 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. This is -3. It's positive. It's positive 3. Because a minus 5. And this is positive 6. 0 remainder. Conclusion. Conclusion is a factor. Okay, verify was the factor x minus 2. Remember opposite sign factor and the 0. The 0 associated with this is x equal to. In this moment, okay. If you continue, if you want, doing another synthetic division using the factor que hay 100 décimos, que es -1 and -3, or well, let's do it in this way. I want to show you another possibility after. Suppose in my paper I select -1. I have no idea why. There are no special reasons. Bring down 1, multiplication is -1. This is 3. This is -3. 0 remainder again. Therefore, the factor x belongs to the polynomial and the 0 is -1. And another 0, no, because it's the linear factor, and the 0, this is x to the 1. It's obvious that the last factor is x plus 3, que is x minus 3. Exactly, we predict. Sorry, we predict in decimals. X equal minus 3. Okay? Because you use it anyway, is in this moment, you say, no, I don't like synthetic division. But I take advantage that this is quadratic equation. You solve this x squared plus 4x plus 3. One more time, we convert to the synthetic division format to algebra. And you factorization by hand. Look at that. XX, using the regular factorization that we studied in intermediate algebra, the combination is 3 and 1, because 3 times 1 is 3, and 3 plus 1 is 4, plus. It's exactly the same, this factor and this factor. Okay, so now, not necessarily synthetic division. You're using combination. And good idea, in my opinion, is the degree of the original polynomial is 3. When you perform the first synthetic division, the new quotient, que es the part I highlight here, this is a quotient, the degree is 2. So when you are doing division, you decreasing the degree 1 time. So you are doing division, degree 3 divided by degree 1. And the quotient, you get that, is degree 2. So because 3 minus 1 is 2, no? And fortunately, I'm happy when the remainder is 0, no? When the remainder is not 0, entonces no, this is not good, no factor. Okay, entonces, you understand very well this idea?
Yes.
Excellent. Okay, that was example 27. Now 28. Bueno, entonces I forgot to say what is the option que you select in 27, guys? What is the option? Okay, in my paper I don't write that. Help me. Is x minus 2, x plus 1, x plus 3, the factor, and the s2 positive, negative 3. I suppose que es D, ¿no? ¿Es o no? ¿Es D o no?
It's D.
Es D. Okay. Now 28. 28 is 5 x cubic minus 24 x squared minus 9x plus 20. Okay, let's move directly to decimals to investigate what is the real zeros que contain the polynomial. Moving to decimals now to see that. Okay, 28. We are doing 28 now. 28, 28. Oh, look at that. I see 28. Okay, we have one factor, one zero positive, que es 5. 5. So x equal 5, and the factor associated with this is x minus 5. We have another negative, que es negative 1, x equal negative 1. The factor associated is x plus 1. And we have another positive, que es 0.4, 0.8. Don't frustrate for the decimal, because actually 0.8 for fifth, for over 5. And you determine now. But okay, 2 is enough, super enough. I copy my piece of paper, x equal 5 and x equal negative 1 is the guy I am using to do the scientific division. Let's come back to the whiteboard. Okay, there you go. Entonces I copy my famous format of the scientific division of 5, negative 24, negative 9, and positive 20. Doing in the order, I did 5 first. Bring down 5. 5 times 5 is 25. 25 minus 24 is positive 1. 1 times 5 is 5. It's a negative 4. And negative 4 times 5 is negative 20. 0 remains. I am happy with this answer. Now I conclude here that the factor is x minus 5. Remember, the factor have opposite sign to the 0. This is the factor, and the 0 is x equal 5. I saw also the negative 1. We have something, no? Negative 1. Let me see, negative 1. Bring down 5. Negative 5. This is negative 4. Negative 4 is positive 4. 0 remains again. Therefore, I conclude that the factor x plus 1, okay, in 0 language is negative 1, belong to the polynomial. So what is because the degree here is 3, no? Degree 3, we need 3 factors. I saw that we have 3 factors. The other factor was 0.8 positive. Where come from that? Well, this is x to the 0. This is x to the 1. Actually, this factor is 5x minus 4. Factor. And so what is the 0? Easy. You take the expression We enforce it to be equal to 0. 5x is equal to 4 divided by 5 both sides. X is equal 4 over 5. Que 4 over 5 es obvio que es 0.8 en decimal approximation. In decimal approximation. Now the factorization, this polynomial is x minus 5. It doesn't matter the order, x plus 1, and 5x minus 4. And the 0 are this, and that. Let me select what is the option that you consider correct. And number 28. 28. 1 4/5. 1 negative 1. And positive 5. Negative 1 4/5. I suppose que 6, no? ¿O no? No? Tell me, guys.
A.
You help me because I make a mistake frequently. Do you understand the idea? So don't waste the time. Also, when you have no internet, when you have no graphical grid, the student lost a lot of time trying different options, doing the zero factor theorem, decomposing the list of the potential, and start doing several scientific divisions in the division. Doesn't work. No, we go directly to the point, because in demo I saw, and demo I can see only the real. The imaginary, no. You see in your moment after in the review what happened with the imaginary. Okay, let's move on to 29 now. 29 say. Yes. 29 say 2x cubic minus 3x squared plus 10x minus 15. I suppose, specifically in this example, we can do that using the regular factorization like we know in intermediate algebra, no? Let me try. I don't know. I am not sure. After, just in case in my paper, I am doing by scientific division, no? But I saw now. Wow! Look at that. Suppose, what is the great common factor in this couple? The great common factor in this couple is x squared, and we have 2x minus 3. And what is the great common factor in this couple? It's supposed to be 5. So plus 5. 2x minus 3. Do you see that? Not always you can do that in this, but in this particular example, I see this in detail. When I do it in the piece of paper, no. When I do it in the piece of paper, no. I'm doing by the scientific long division, the scientific division. Again. Okay, now. I saw that 2x minus 3 is a common factor, 2x minus 3, and we have x squared plus 5. This is the factorization of the our polynomial, and that's it, end the story. Because I know that this guy is irreducible quadratic, no factorization, in the real field at least. Do you see? To answer the questions about the zeros, well, the zero are the only real zero that we have is this. 2x minus 3 equal to 0. 2x equal to 3 divided by 2. X is equal to 3/2 or 1.5. if you prefer in decimal. This is the factorization, and this is the only unique real zero that we have. Wait. So I go back again to the, I suppose que es the option B, no? A ver, let me see, B, right?
Yes.
I am doing well. Just in case, I am not sure. To make super sure, I go to decimals. Because in decimal, I can see only 1 0 and 1.5 or 3/2, either way. Normally, in decimals, the intercept on the point is expressed in decimal. No, okay. I understand. Let me try. Share the screen of decimals. Okay, there you go. I found. Do you see decimal now? Okay, we are doing 28. Look at that. 28 is this polynomial. Boom. Do you see that we have only 1 0? One real zero positive. Because the other, que corresponde with the factor x squared plus 5, you never see because they are imaginary or complex. Specifically imaginary in that case. Any question, guys? In this case, it was easy, the factorization, not necessarily scientific division. We are doing by factorization by grouping. I suppose you remember anyway, factorization by grouping. Yes or no? Yes or no?
Yes.
Yes, it's easy. And one clue, well, the clue is depending on the number involved in the problem. No? However, 4 term, 1, 2, 3, 4, because you separate by a couple, no? Of GCF in the first couple. This is the GCF in the first GCF and the first couple is x squared. Factor out. This guy is this guy. And the GCF and the second couple was 5. This 5 was this 5. Good. Okay, let's move on to 30. 30 is similar. Yeah, it's similar. Wow, too much probably. 30, 32, 33, 34. Wow, it's crazy. But okay, it's good to practice, no? And we have one more day. So my intention is in one moment stop and we continue Thursday, right? And you feel strong? I'm supposed to. Remember, I am aware, I can do 1,000 problems. However, if you don't practice by yourself, you never learn this very well. Okay, what is the problem we are doing now? Okay, I suppose it's this. Now let me see I select. Yes, it's that page. Yes, it's that page. Okay, 30 now. 30 now. Solve the equation, the real number against system. Okay. Okay, 30 is 5 x to the 4th power minus 7 x to the cubic power plus 22 x to the 2nd power minus 28x plus 8. This is our polynomial degree 4. Degree. To say I need to, in this specific question, factorization, nice, using only real factor, no irreducible quadratic. Well, no irreducible quadratic, yes, but you don't decompose in imaginary, no. And now find the zero, the real zero. It's the goal in this problem. Okay, entonces, well, I have no idea, totally lost. I go to decimals, 30 problems. Wow. I am checking first in my laptop. But let's move on to my computer now. My computer, I want to share with you decimals one more time. Okay. Okay, we are doing number 30 questions. Look, this is the polynomial that's given. I discover two factors, two real, positive. Que es 1 and 1 and 0.4. And 0.4 and 0.4, you know, in decimal is 2 over 5, 2/5. Okay, 4 over 10, when you reduce the lower term, 2/5. And the factor that you discover in decimal is 1. So you are doing central division one time using 1, and the second time using 2/5 or 0.4. Either way, in decimal fraction, the way you prefer. So the degree of the original polynomial is 4. When you are doing two scientific division, you decrease it by 2. And by 2 is easy. By 2, you can use a regular factorization, or let's see what happened, depending on the problem. No? Maybe it's a reducible quadratic, something. I don't know. Okay. So I know I copy my piece of paper. 1 and 0.4. Okay, positive both. Come back again to the whiteboard. Okay, good. I have here whiteboard. Wow. You know, without these tools, without decimals, it's a very, very complicated problem. However, in decimal, I go directly to the point. 5, -7, 22, -28, and +8. And you divide it by 1. Okay, what's the first one? Bring down 5. 5 times 1 is 5, and -2. -2 times 1 is -2, is 20. 20 times 1 is 20. It's -8 times 1 is -8. 0 remaining, happy. Now I discovered that the factor x -1 below. This is a factor. This is the organization factor and zeros. X equal 1. Okay, by the way, this number is the same number of these. When it's opposite in the factor. The other guy is 2/5. Okay, 0.4. I saw in decimal x equal 1 and x equal 0.4. 0.4 is 4 over 10. Okay, when you reduce it to 2/5. Suppose 2/5. You say, Professor, I never see before scientific division using fraction. Well, okay. You see it the first time now. Bring down 5. Multiplication 5 times 2/5 is 2. So bring it 2. 2/5 times 5. Cancel out the 5 is 2. The 2 minus 2 is 0. Multiplication is 0. This is 20. And 20 times 2/5 times 20 is 40 divided by, it's 8, no? It's 8. 8 again. I prove, wow, fantastic. The factor, let me see how you write the factor. The factor is actually, the factor is x minus 2/5. Que is equal to 5. Que is 0.4. Exactly, we saw in decimals. Okay, entonces now I have no more real, only 2 in this example. The rest is the quotient, that part. Well, that part is, this is x to the 0 power, this is x to the 1 power, and this is x to the 2nd power. Actually, is the factor is 5x, wait. No. Fi x squared. No x, 0 is missing the x part plus 20. Bueno, professor, okay, I understand that. However, you can factorization like a intermediate algebra. I discovered the great common factor here, phi x squared plus 4. Now I see here that this is irreducible quadratic. That is the reason in decimal I don't see any more 0, only 2, because this is imaginary, right? Entonces, now, what's the fantastic conclusion? Well, the fantastic conclusion is the factorization is the collation of the factor. Okay, the collation of the factor is x minus 1, x minus 2/5 times phi x squared plus 4. I guarantee you that this expression and the polynomial is equivalent. However, it's not nice. There are no reason to write like that. See, you multiply this times this and this times that, you have x minus 1, phi x minus 2. And this phi disappears because I put inside the parenthesis in the middle x squared plus 4. And this is the nice factorization for the our polynomial. And the 0, the real 0 is 1 and 0.4 or 2.5. Exactly, we predict in this one. Okay, 30, 30, 30. 30, 30, 30. 30 is, is help me, guy. I suppose que es, no, es sí, ¿no? Es sí.
Yes.
Es sí. 1 to 5, que es 0.4, x minus 1, 5x minus 2. They want to write no in this ugly way. This is not wrong. It's just cosmetic because there are no reason. No? So you put a 5 here. You see that if you include a 5 inside the parenthesis, you eliminate the fraction. It's okay. So I propose you stop here. Too much for today. Remember, we have 30 to finish. So now, see, we are doing too much today. We have nothing to do. We have only 2 pages for doing 30. Okay, guys? So you are aware your situation, your future situation. Okay.